As Keller said, we're going to focus on the Tech Check and the BD2100. Up until now, we've really focused our training on the Navigator Pro, which is a much more feature-rich and kind of sophisticated meter. The Tech Check and the BD2100s are kind of more our bread and butter and easier to use instruments. So we're going to get started with that. Before I get into the meter section, I like to talk a little bit about how different types of moisture meters work. This diagram illustrates on the left like a pin meter or a hammer probe in this case that's used on a pin meter, and on the right a surface or a non-invasive meter. The material that's shown simulates hardwood flooring over a wood subfloor. The pin meters work by measuring the electrical resistance or the electrical current between the 2 points of contact. So if we look at, just bear with me a second, if we look over here where I'm highlighting, when the pins are penetrated into the material, it's just looking at that very point between those 2 points of contact, and it's measuring the current that's flowing through. There are some advantages to this method over the surface meters, and there are some disadvantages. So, what we're going to show here is how the two types of meters really work together, especially in the restoration industry, because they kind of give you different information and point you in different directions, but they really complement each other. The pinless meters work using capacitance, which essentially means that a signal is sent into the material, and then as you see here, it kind of gets bounced into the material and then sent back to the meter. Just a couple of things to consider about pin versus pinless, and we'll be talking about this throughout, but one of the advantages with a pin meter, and especially when you're using a probe like this, is the pin itself, and you can't see this in the diagram, but the shaft of the pin is coated with Teflon. So the reading is taking place just at the tip of the pin. What this allows you to do is what we see here. You can penetrate just below the surface of the floor. You can go into the floor a little bit further or through the floor to the subfloor. And each time you go in a little bit further, you may or may not get different readings. But because you're reading just at the tip, you're going to pick up whether or not there are differences in the moisture level at the subfloor versus the top floor. So that's one of the main advantages to pin meters, especially using an insulated pin like this one. With a non-invasive meter, the depth of penetration is typically between about 1/2 and 3/4 of an inch. And we'll talk a little bit about some of the limitations there, but the main difference in terms of what information you can find is you're not necessarily going to be able to get down like through a floor to a subfloor or through drywall into the insulation, because there's a limit to the signal that's being sent out. So the surface meters are really good, or the non-invasive meters are really good to quickly identify problem areas. And then when you find those problem areas or those elevated levels of moisture, you go in with your pins to get more definitive results. So again, that's a little bit of an overview on just the technology. With each technology, with each type of meter, there are different things or different factors that will affect your meter readings. With pin meters, the moisture content is the most important thing, actually, and with pinless. Because in both cases, the higher the moisture content is, the higher your reading is going to be. The lower the moisture content, the lower your reading is going to be. Another factor with pin meters is the temperature of the material, and this relates to wood materials specifically. And then a third factor is the material that you're testing. I put temperature and material sort of hand in hand because moisture meters, when they were originally developed, were primarily used on wood materials, and the calibrations for them were done on Douglas fir at 70 degrees Fahrenheit. So Douglas fir is the material, 70 degrees is the temperature. Both of those factors are important in the calibration because if we go to the material first, each type of wood has different electrical characteristics. So that resistance or that current that's flowing between the 2 points is going to act differently and therefore give you a different reading. With temperature, if your temperature of the wood rises, that flow of current is going to move more quickly and more easily, so you're going to actually get a higher reading on your meter, not necessarily higher moisture content, but a higher indicated reading. Same thing if you're testing materials that are well below 70 degrees, you're going to get lower than actual readings. Now, the reason I'm bringing this up is for a couple of reasons. The temperature is important in restoration, particularly when we're working with heated drying systems. So we know that the ambient temperature can get into the hundreds, 110, 115, 120 degrees, and that's also going to mean that the wood that you're checking is going to increase in temperature as well. So when you're using one of the meters that we're talking about today, the Tech Check or the BD2100, the recommended way to handle temperature corrections is first of all to use an infrared thermometer and just point it at the surface of the wood, find out what the temperature of the wood is, and then when you drive the pins into the wood, you take your reading, and then you look at a chart that we supply with the owner's manual that helps you to adjust for the temperature. Again, a higher temperature is going to give you a higher reading than the actual moisture content. So you would be correcting down when you're reading elevated wood or elevated temperature of wood that's higher than 70 degrees. Same thing with the material. Because the meters are calibrated on Douglas fir, different types of wood can give you different readings. So we give you a correction chart as well for the material that allows you to correct for the differences in the material. For those of you that are familiar with the Navigator Pro, you'll remember that it has a built-in temperature correction feature, and it has about 10 or so different materials that you can choose from. So it does these corrections automatically. And that's, again, why I'm kind of making a big point about both of these things, because they need to be handled manually with the Tech Check and the BD2100. The last item that affects your meter reading is the electrode type. I had talked a little bit about the insulated contact pins. We also have pins that are non-insulated. They're just steel, pins that go into the material. I don't put a lot of stress on this because there's not a huge difference in the readings between insulated or non-insulated, but it is a factor that has some bearing on the readings. So just kind of going back and summarizing, these 4 things are things that affect your readings. It doesn't mean the meter is more or less accurate. For example, Tech Check is not less accurate than a Navigator Pro. It's just that when you're dealing with different temperatures and materials, you need to make a manual correction versus the meter correcting for you. On pinless meters, the surface conditions play a big role in the meter readings, and the smoother the surface, the more consistent your reading is going to be. And this is really a function of the pad or the sensor plate making good contact with the material that you're testing. If it's a smooth surface, the pad is going to make nice firm contact, and you're going to have more consistent and more uniform readings. If you've got a little rough, whether it's a textured wallpaper or paint, or even kind of a little bit of a rough concrete surface, when you place the meter on that surface, there's some air pockets, just little air pockets that are created because of the unevenness in the surface, and that's going to give you typically a little bit lower reading, a little bit less consistency in the readings. Excuse me. Surface moisture also plays a role. Again, let's go back to that flooring example. If the top of the floor is, has condensation on it, or is just wetter than what's down at the core, the meter readings on pinless meters are going to be skewed more toward what the surface is like. And the reverse is true. If you've got moisture down at that subfloor, but the top layer is drier, the reading that you get with a pinless meter is going to be lower than what's really happening throughout that whole material, meaning subfloor and top floor. So that's important to recognize too, because again, it's a good indicator as to where you might start with the surface meter, get an idea as to what's going on, and then go in with pins to really identify where the source of the moisture is, if there's hidden moisture. The other item which affects pinless meters is hidden material. Typically, if you're going, on drywall in commercial buildings, most of the time is used with metal studs or electrical boxes. That can be picked up by the scanner on the meter, and that could skew the reading as well. So it's just, important to recognize that these things could affect your readings, and you just want to be on the lookout for them. We're going to start with the tech check. And I just want to give a little overview as to what I'll cover today. We're going to go through the basic operation of the meter, which includes using it in the pin mode, using it in the non-penetrating mode. And so the tech check is a 2-in-1 meter. It's a pin meter and a non-invasive or non-penetrating scanning meter. So we'll go through both of those different modes. There's some special features on the meter that include a reading hold feature that allows you to freeze a reading on screen. There's a backlit display that helps you to see the screen in poorly lit areas. And there's also an alarm that you can adjust to alert you when you've reached a certain threshold. So if you've established that there's a dry standard or a level that you don't want to go above, you can set the alarm to that level, and any reading above it is going to just beep at you as another alert. Then we're going to cover some brief practical applications, just using it on drywall and on wood, and that'll cover that. The basic specs for the tech check are listed here. The pin penetration is 5/16 of an inch, and that's for the pins that are mounted on top of the unit. The connector over here, which will allow you to attach a probe or electrode to, gives you the flexibility to attach probes that have longer pins. The slide hammer that we saw in the line drawing before has pins that will go an inch and a half into the material. So you do have more flexibility when you attach different probes. The scanning depth is about 3/4 of an inch. And I say about 3/4 of an inch because it does depend on the material that you're testing, but typically it does get in 3/4 of an inch into the material that you're testing. In pin mode, this meter is calibrated for wood, for Douglas fir, from 6% to 60%. So when you're checking wood materials, you will get actual moisture content readings that go from 6 to 60. When you're scanning, you'll get readings that go from 0 to 300, and this is on what we call a numerical reference scale. These give you relative readings. It doesn't give you a percentage moisture content. And the reason for that is largely due to the fact that with these non-invasive meters or the scan meters, it's not possible to develop calibrations for very specific materials. So they're flexible because they can be used on a lot of different building materials, but they need to be used as comparative readings. Just to get a little further into that, if you've used or if you sold any of the GE products, their non-invasive meters go from 0 to 1,000. The Tramex Moisture Encounter, which is pretty popular in the industry, goes from 0 to 100. Ours goes from 0 to 300. The numbers in and of themselves don't mean a lot. It's really, what's important is to find an unaffected area with the scanner, use that as your baseline or your dry standard, and then when you find areas that are higher than that, you know that there's something else going on in that material. So again, even though the scales are different, they give you different ranges, it's more important to compare readings within each job than to try to compare readings between different types of meters, because again, the scanners are more of a qualitative or a reference scale. The other item that just comes with all of our meters is a hard plastic carrying case. Keeps the meter nicely protected. We offer a 1-year warranty, and I don't have it here, but all of our meters come with a 9-volt battery, so that's all included. It's ready to go out of the box. This is just a little outline of the buttons more than anything. I mean, we already talked about these guys up here with the pins and the connector. Of course, we have a digital display. But the 5 buttons are really what drives the features of the meter. The center button will power your meter on, and it will also hold a reading on screen. The left button will put you into pin mode, and again, that will give you readings on wood from 6 to 60%. The right button will put you into scan mode, again from 0 to 300. The bottom button will activate the backlight, and the backlight will stay on for 20 seconds and then power itself off, and that's just to save battery life. So anytime you want to reactivate the backlight, you just hit it again and it'll power it back on. And then the top button is how you adjust your alarm value for either pin or scan mode. If you look here to the side, you'll see the little beginnings of a decal that are on the side of the meter, and this is just a representation of the buttons, so it's a quick reference as to what each of them does. So again, left is pin, right is scan, top is alarm, bottom is light, and then the center is to power on or hold a reading. There's no power off on this meter. The tech check will power off after 2 minutes if there's no button activity. So every time you push any of the buttons, it reactivates the timer for 2 minutes, but it will shut itself down after 2 minutes. We're going to get right now into the operation of the meter. To power the meter on, you press and hold the center button. I'm going to refer to that as the select button or the select key. You need to hold it for a couple of seconds until the screen appears. It'll show the software version on the screen, and then you can release it, and the meter will stay on. To use the meter in pin mode, we're going to use the pins that are on the top, or connect a probe to the electrode that's right to the connector that's right next to it. You'll have already pressed the left button to get into the pin mode, and this is what the screen looks like. So it gives you an MC, moisture content value. There's a little dry to wet indicator, which is just another visual indicator that kind of fills up as you get higher moisture levels. This is the alarm value, which we'll talk about in a minute. And when you're probing, if you have the pins in material and you want to freeze that reading, if you want to capture that reading, you just press the select key, and it'll display hold on the screen, and that way you can look at it or record it, write it down if you'd like to after. So that's a nice feature, especially if you're reading in areas that are difficult to see. With the scan mode, first thing is we're going to press the right button to get into the scan mode. The sensor on this meter is in this outlined area, so it's kind of that head of the meter. That is the scanner. One thing I like to mention is you'll notice that it's a flat back, which is different than the GE products, which have a little bump out on the back of their meters. We did this for a reason, and what we found is when you're using that bump out, it's a little bit easier to actually hold the meter, so it gives you a little bit more leverage. But if you change the angle at which you're holding the meter against the material that you're testing, the readings change. So we felt that a flat back will give you more consistency in the angle and the pressure that you're putting on the surface itself. The scale looks very similar to the pin mode. Again, it always tells you what mode you're in. Just keep in mind here the number that's shown doesn't have a percent sign. And then again, that's because it's not a percentage, it's a number on a range from 0 to 100. Again, you press the select key if you want to freeze a reading on screen so that you can write it down. And you can always toggle back and forth between pin and scan just by pressing the left or the right arrow. So the left or the right button. So that's just how you go back and forth between the screens. The hold feature I essentially covered, whether you're in pin mode or scan mode. If you're at a reading that you would like to write down, or if you're in an area where you can't see the screen, you can always feel for that center button, which is a nice feature, and just press it. The word hold appears on the screen, and the reading is frozen on screen until you release it. So that's really a nice feature, like I said, especially if you're in an area where you just can't, you can get to the material, but you can't really see the screen. And that's something that our competition doesn't have. The backlight, this is unfortunately not a great illustration of how it works, but because it's a little bit fuzzy, but you turn on the backlight by pressing the button below here. And again, like I said before, it activates it for 20 seconds, makes it easy to read in dark places. The alarm setting is accessed by pressing the top key 3 times, and you'll get into the alarm sub-menu, which looks like this. When the meter is shipped from the factory, the alarm is set to off. If you press the select key, it will turn the alarm on. And then you can use your left or your right keys to go up or down scale to a higher or a lower moisture level. And then you just click on done or press, select done to go back to the read screen, whether you're in pin or scan. I want to mention something about the alarm, again, that makes it unique when compared to other products in the industry. If you look at a GE meter or even the Tramex Moisture Encounter, they have buzzers or alarms, but they're preset at the factory to a number. Because you can adjust our alarm to whatever number you want, it makes it more valuable. And if we go back to the idea before we talked about a dry standard or a baseline reading, this is where the adjustable alarm really comes into play. I like to use my office as an example. My office has some sort of vinyl, a little bit of textured wallpaper. And if I scan the wall, I get a reading of about 54. If I go out into the hall, which does not have wallpaper, it's just flat latex paint, I get a reading of about 34. So what that tells us is that even within the same building and in the same environment, a dry reading or a dry standard is different depending on the material that you're testing and depending on the wall covering. How does that factor into the alarm? It gives you a lot of flexibility, because if we're checking in my office, we can set the alarm for 55. It's in 5-point increments, and we know that that's a number that's considered a dry standard in that particular environment. We set the alarm for 55. Anything that reads above 55 is going to beep at you. If we go into the hallway and we set it for 35, anything above 35 is going to beep at you. Again, this differs from the GE and the Tramex because they're set at preset values. But what I'm, trying to drive home here is that dry standard or that target moisture level can be different and will be different, at different job sites and with different materials that you're testing. So I make kind of a big deal about the adjustable alarm because I think it's a really good feature and one that Delmhorst only offers. I got ahead of myself here. Okay. Once you set your alarm, the value of the alarm will show up in the lower right-hand corner of the screen. So if you're in pin mode, it'll tell you it's set at 6%. If you're in scan mode, it would just have a number from 0 to 300, whatever you set your alarm to. So that's the basic operation of the meter. We covered how to use the pin mode, how to use the scan mode, the special features, which are the reading, hold, the backlight, and the alarm. And now I'm just going to spend a couple of minutes on some very basic practical applications. Again, if we think about how we evaluate a job or how we get onto a water damage job, we typically would go in with the scanner and scan larger areas to establish your dry standard. So, and I don't mean to keep repeating myself, but it's an important thing. Here we're going to look at that 0 to 300 scale. And again, those numbers, don't really mean anything by themselves. But what you want to do is find an unaffected area and capture that number. In this case, it says 22. So that would be our dry standard. Then we could set the alarm if we want. In this case, we'd set it to 25 because it's the next closest number, or you could set it to 20 if you want to be more cautious. But, either way would be really acceptable. And this way, you can continue scanning the surface and, just listen for the buzzer to go off. When you find an area where the buzzer goes off, you know that there's something else going on there. Typically, that's when you would take your pin readings. I just said this, so you're going to scan the area and listen for the alarm. The pin mode is a little bit different, and I say here we're using the pin mode for more precise readings, but precise might not be the right word, but if we go back to what I had just said about the scanner, when you identify that there's elevated moisture levels, that's really when you then go in with your pins. And you can use the pins on the top if you're just going into the drywall. We're going to show you an electrode that can be used to go through the drywall. But again, the pins can help you identify really the source of the moisture. If it's hidden moisture, if there's more closer to the surface or further away from the surface. When you're checking wood, you want to try to push those pins fully into the wood and parallel to the grain. Parallel to the grain is not going to make or break the readings, but it does give you a more consistent reading when the pins are going in the same direction as the grain of the wood instead of against the grain. On non-wood materials, like this, for example, is drywall, keep in mind that the meter will read on a relative basis only. So if we look at the screen here, it says 6.1%. It's important to recognize that that doesn't tell us that there's 6.1% moisture content in drywall. It's 6.1% on a wood scale. You may hear the term wood moisture equivalency scale. It's the same thing. And just to give you kind of a point of reference, on a wood meter, a reading of 20% on drywall equates to an actual moisture content of 1% on drywall. So there's a very big difference between the actual reading on the wood scale and the actual moisture content on drywall. So again, I'm sort of making a big deal of this point because you can use the pin meter on drywall. You can push it through to the insulation. The numbers that you see are going to show up as percentage moisture content for wood. You need to look at those just as comparative readings. So in this case, in a dry area, this would read more like, well, actually this is about right. This would read about 6% or so on drywall. And then you might go to a wet area and it may read 25 or 28%. So again, you're just looking at change or comparisons between two different places. The special features I basically covered, but again, the hold feature I think is a great feature because it allows you to just freeze the reading on screen if you're checking an area that you can't see. The backlight, this is a little bit of a better illustration of how the backlight really glows in a dimly lit area. And then the alarm we talked about as well. And again, those three features are really, I think what make the tech check unique in the industry. The next item I want to go over is the 21E, which is our insulation electrode. This comes in most of the kits that you buy. It has these pins that are actually 4 inches in overall length but have a penetration of 3 1/4 inches. Like we talked about earlier, they're coated with Teflon, so the reading that you take is just at the tip of the pin. The connector, if you're familiar with any Delmhorst products, this connector is the same for all of our electrodes. So any one of our meters will accept any one of our electrodes. Using the 21E, the most typical use is for insulation. And the first thing you want to do is attach the probe or the connector to the top of the meter. Make sure you screw that down. And then just stick the pins through the drywall into the insulation. And again, this is where the benefit of that coating comes into play because you've got 3 inches, 3 1/4 inches here that you can play with. So you can poke it just through the drywall and take a reading. You can go in halfway, the halfway point on the pins and then all the way in, and you could get different readings. So because you're reading just at the tip, you may see that there's more moisture further into the wall cavity in the insulation, which is good information because it tells you that you've got to make certain decisions about how you're going to dry that out. Or you may see that there's more moisture closer to the drywall. So those pins and those insulated pins really help you to identify the source of the moisture, which is really important. And again, when you're reading insulation, those numbers on the screen should be taken as relative indicators only. You're going to compare, unaffected areas to then wet or affected areas. That covers the tech check. It's a really easy to use, nice 2-in-1 meter. So you do get the benefit of the scanner and the pins in a very simple to use meter. I wanted to just give you this link. We recently rolled out an online training course for Tech Check, which is similar to the presentation I just gave you. But if you go to this site and then click on Tech Check Training, and then follow the instructions to create an account. It just asks you for a username and a password. It actually will run you through the operation of the meter. It's broken up into a couple of sections, so if you need to repeat anything, you can always go back. And then there's a short quiz at the end just to kind of, test your knowledge based on the training. So I wanted to let everybody know that this is available now for the Tech Check, and we're working currently on one for the Navigator Pro, which is going to be very in-depth training on the Navigator Pro. The advantage here is that whether you want to get more information to help you sell the product better, or we want to direct your customer, if they're interested in buying it, or just to learn how to use it, these are going to be online, available at any time. And Ron, if you want to just mention where they can access this from the Interlink Supply website, that would be great too.
Sure. You don't have to bypass Delmhorst, but if you forget the cdktraining.com part, if you just go to interlinksupply.com, under the product number, which we use AC8208, excuse me, under the more info on Tech Check, you will see a link to take you to that training. And again, more are coming soon.
Yes. So this is a start, and I think it'll be great. So again, the next one is going to be the Nav Pro, and then we'll keep rolling it out from there. And I'll make sure Ron is aware as soon as those come out. Okay, so we've covered the Tech Check. I want to talk a little bit about the BD2100. This has been around in our assortment for many years now. I'm sure many of you have seen it, in the field or have sold it. It's a pin meter only. So again, we've got the pins on the top with the connector next to it. So it's not a 2-in-1 meter. Some of the features here I just want to outline. Again, the pins on the top will have a penetration of 5/16 of an inch, or you can use the connector on the side if you need to get pins that are longer or for different applications. One of the nice features about the BD2100 is it has different scales. So again, it's only a pin meter, but it offers you a wood scale that reads from 6 to 40% on Douglas fir. And again, if you're using this on other wood materials, there is a correction chart that you can refer to adjust, the reading on screen to the actual moisture content. If, back up, another very nice feature, and this is, again, a Delmhorst exclusive, is it has a drywall scale. So on the Tech Check, we talked about using those readings on drywall as relative readings. The BD2100 actually gives you percentage readout on drywall, and it goes from 0.2 to 50%. 50% would be literally running water. The reason we have the scale for this is because it's also used by the gypcrete manufacturers, and they need to check at those high levels. But in restoration, just to give you an idea, you really want to see drywall below 1%. 1% is about the threshold where there's, either moisture or the potential for mold growth. If you were to set this meter to drywall and push it into the drywall and an unaffected area, it's going to read somewhere around 0.2, 0.3, 0.4%. So the numbers are very low. But again, this is a nice feature because you can actually give, it gives you a quantitative measurement on the drywall. It also has a third scale for what we would just say non-wood and really non-wounded, non-drywall, that goes from 0 to 100. This is similar in concept to that 0 to 300 scale on the tech check, in that the numbers don't indicate a percentage moisture content, but they give you a relative reference. And you can use this on insulation. That's typically where it will be used if you're going through your drywall into the insulation. You can use it on concrete and also some roofing materials, which I know we don't get into too much in this industry. But so the BD2100 has the flexibility of those 3 scales, which is really nice. Again, special features, the drywall scale being exclusive to Delmhorst. It has a user-adjustable alarm, similar to the tech check. It also has a built-in calibration check, so you can check in the field if the meter is electrically in calibration. And again, all of our meters come with a plastic carrying case, the hard plastic carrying case, a 1-year warranty, and a 9-volt battery. Just again, a look at the meter itself. We've got the pins and the connector, which we've talked about, the digital display. The water droplet button is what you're going to press to take a reading. So when you insert the pins in the material, you'd press that button, and it'll display a reading for about 2 seconds. The check mark is to check the calibration, and I'll go over that in just a minute. The asterisk is the scale button. So that's what allows you to choose from wood drywall or that 0 to 100. The pound sign is the set point for the buzzer. So that's what accesses the alarm value and allows you to adjust the alarm value. These 3 things, the LEDs right here, which are green, yellow, and red, they gave you a visual guide of dry, borderline, and wet readings. I don't put a lot of emphasis on these because they're factory set. They're not adjustable. So we talked earlier about the dry standard and how it could be different in different environments and on different materials. That's where the alarm comes into play, and the ability for you to set the alarm, it gives you more flexibility. These are factory default set. So even though they're a little bit of a visual guide, I don't put a lot of weight on them because, like I said, you don't have the flexibility to adjust what's green, what's yellow, and what's red based on your assessment of that particular job. The meter's really easy to use, so we'll just take a minute or 2 to go through the operation of it. The first thing is checking the calibration. Basically, all you would do is press the read or the water droplets and the check button simultaneously. The meter is in calibration if it reads 12%, 12.0, and it does have a tolerance of plus or minus 0.2%. It's important that you don't have the pins inserted into any material or that they're not touching anything when you're checking the calibration, because that's going to override the actual calibration check. Again, this is just an in-field check that the meter is in calibration. It's not necessary to do it every time you use the meter, but it's a nice feature just to check it periodically to make sure it's calibrated. Our guideline is if it falls outside of that 12% or 11.8 to 12.2, the first thing to do would be to change the battery. If with a new battery the meter is still not calibrating or checking calibration, it does need to come back for service. That's just one thing to keep in mind there. To set the scale, and again, this is to choose your wood, your drywall, or your reference scale, you're going to press the scale button. If you press the button and release it, it's just going to display the scale that it's currently on. So if you just don't remember what you set it to and you want to make sure, which is really important actually, just press it and release it and it'll tell you the scale that you're on. Now the display on this meter is more limited than the one on the tech check. There's no alpha reference here. It's all numeric. So your scale is going to say 1, 2, or 3. And scale number 1 is the wood scale. Scale number 2 is the drywall scale, and scale number 3 is the reference scale. And I think I confused 2 and 3, and I have to remember to come back to that just to reconfirm. But again, if you know that what 1, 2, and 3 is, then you just set it to that value. And to change the scale, you're going to press and hold that button. So if you press and release it, you're just going to display the scale you're on. If you hold it down, it'll just scroll through, from 1 to 3, and then it'll just circle back to 1. And then, again, you release it when you've hit the scale that you want. This button acts sort of as a down arrow. So if you've activated the scale mode by pressing the asterisk, and then quickly press the pound sign, that acts as a down arrow, and the asterisk would act as an up arrow. So you have two ways of adjusting the scale. You can either just hold the asterisk until you get to where you want, or flip between the two buttons to go up and down range. I mean, it's only 3 options, so it's not like you're cycling through, a very long or wide range of numbers. So either way is fine. But again, just keep in mind, to get to the scale setting is always the left button or the asterisk. And again, you want to release it when you find your desired scale. The alarm is exactly the same thing, except that you're going to activate it by pressing the set point or the pound sign. Again, if you press and release it, the alarm value for the current scale will be saved or will be displayed. So if you just want to see what it's set to and not mess with it, just press that button and release it. If you hold the button down, it's going to scroll to a higher value. Or if you press the asterisk in this case, it's going to act as the down arrow. So like we said in the scale setting, these two buttons really act as up and down arrow keys once you're in that mode. And they're reversed. Keep in mind they're reversed because in the example before, we're going to use the asterisk to get into the scale setting. That also will go up scale, and then this would bring you down scale. In this case, you're going to press the pound sign to get into the alarm mode, and if you hold it, it'll go up scale. If you release it and press this one, it's going to go down scale. So just keep that in mind. So they're really function keys and up and down arrow keys depending on what you're in. And again, you're going to just release the button to stop at your alarm setting, and then the display will disappear and you can start taking readings. The BB2100 is typically packaged with the meter, the carrying case, a couple of extra pins for the top of the unit, the 21E insulation electrode. So that's typically how the basic package comes, and that's your part number AC8210. All of our meters come with rugged construction, and we do pride ourselves on the fact that our meters are really built for the environment they're being used in, which can be a little bit of a rough environment. If you look at our connectors, our contact pins, everything's a little bit more robust and even a little bulkier than some of the other meters on the market, but we've really done that by design because it's shown that they hold up better, and especially the connections. When you have to screw down the connector for an external probe, you've got a solid connection there. So those are the kinds of things that Delmhorst really works toward. The plastic carrying case I had mentioned before comes with all of our meters. Anything that Bridgepoint buys from us is big enough to house the 26ES, which is the hammer probe. So if you were to buy a kit that didn't include a hammer probe and you want to add that later on, you always have a slot for it in the carrying case. So you can keep everything together. And then again, the 9-volt battery and the 1-year warranty on all of our products. The last thing that I want to touch on is how you would handle if you need service for the meters, and whether your customer is going to send it directly to us or you're going to send it from your store. That's up to you, but we can work with the customer directly, with the end user, or with you as a branch. It doesn't have to go through corporate. What we do ask is that you go to our website at www.delmhorst.com. That's our homepage, and then click on Product Support, which will bring you to this menu or this page, and then you want to click on the Repair Return Data Sheet. If I go back one, there's a Servicing Your Meter choice there too, which gives you some other instructions, but this repair return data sheet is really all you need. And it's a PDF file that looks like this. And you know, we don't require you to send this in. It's not there's not a return authorization that's needed, but we do ask as much as you can to direct your customers to this page when they send in the meter, because it really helps us get and process the repair more quickly. All the contact information is there. They can write notes as to what the problem is. You can even authorize you know, a certain dollar amount for a credit card, so that just speeds things along. Typically, we run about 2 weeks on repairs right now, so that's 10 business days from the time it comes here to the time that it ships. We can always do better if you need it. If your customer is in a pinch, we just need to know in advance, but we can always do better. But that's what our guideline is. And that's the end of our presentation. I do like to leave with this screen because our 800 number or our info@delmhorst.com are 2 ways for you to get a hold of us. We encourage you to take advantage of our, you know, of our customer service staff if you need help with selling the product, or if your customer needs help with troubleshooting or using the product. That's really what we're here to do, is to help make your job easier. So don't ever hesitate to contact us. We're a small company. We don't have a huge staff, but we're very good about either picking up the phone or getting back to you if you need to leave a message.
Hey, Paul, we do have a few questions that were asked during your presentation.
Good.
The first is from Anthony Stickle at CleanServe in Ohio. He asks for you to please explain why the pin mode high limit reading is set at 60 on the tech check.
That's a good question, and I don't have a good answer for it. To give you a little background, the pin meters are good. I mean, they're most accurate from about 6% to about 28% on wood. Once you get higher than 28% on wood, the wood reaches what's called a fiber saturation point, which means there's literally free water going through the wood, and there's so much water that the resistance or that current flows through so easily and so quickly that the readings become a little bit erratic. Because the tech check, and this is probably the best way I can explain it, because the tech check may be used in an environment where the temperature is higher, you may get readings, and you could very well get readings in the 30s or 40s. 60 is going to be unusual, but you could get readings in those higher numbers that are a result of wet conditions and high temperature levels. So what it does is it allows you to view a reading that may be, you know, a false high reading, but then correct it down based on the temperature. Does that help?
I just asked him if that. You know,
okay.
Question.
Okay. And I can always, you know, deal with that individually too.
Okay. The next question I got was from Jamin Thompson at Express in Montana. He says, I thought most materials conduct electricity better than cold. Wood works opposite of the norm?
Yeah, this is, I mean, the way that I understand this is that, and the way I describe it is, when wood is colder, the current that's running through it is actually going to be harder for that flow of current to go through. I am under the impression that that same thing is for most materials. So I might need to look into that a little bit to better answer the question. But, you know, with wood specifically, the colder the temperature or the lower the moisture level, you know, the harder, I always kind of put it in terms of just like thinking about how easy it is for the conductivity or for the current to flow between the 2 points. The lower the temperature, the lower the moisture level, the harder it is for that to pass through, so you're going to get a lower moisture reading. And again, my understanding is that that would follow suit for pretty much all materials. But I think I need to look into that technically. So if Taylor, if I could have his contact information, I can probably do a better job of finding out whether or not that is opposite of the norm. I never thought that it was, but
that might be something we may want to, since there are several on here that have heard the question, I may want to send out to all of them.
Sure, not a problem.
Nonetheless, I don't know if the explanation is getting through, but it is true for the materials that the hotter the materials, the higher the reading is going to show. The colder the materials, the lower the reading is going to show.
Right. And it all has to do with, I mean, I don't want to use the word density because that's not really it. But if you think about wood for a minute, it's like a sponge. So when it's hotter, it opens up a little bit. When there's more moisture in it, it opens up a little bit. The cells of the wood actually open up, which allow the current to flow more easily. If it's cold, if it's frozen, think about what happens to a cold. Cold will shrink something, so it'll tighten up. The cells of the wood will tighten up, which will make it more difficult for the current to flow through. That might be maybe a little better way for me to explain it.
Okay. The next is a statement from Jamin saying that the adjustable alarm would be especially useful in places like Louisiana, where even the dry standard would probably be wetter than most alarms.
Exactly. Yeah, absolutely. And that's why we feel so strongly about the adjustable alarm, because it gives you flexibility to adapt for the conditions that you're in. So, good point.
That is all that have asked. Any questions?
So Taylor, if you don't mind, actually I'll know to look at